start. Okay, everyone, and welcome to our very first lecture for Math 140. Math 140. And the textbook is The Basic Practice of Statistics. Okay, and we are starting with chapter 1, which is a pretty good place to start. So part 1 on exploring data. And in particular, we're going to start with chapter 1. And what is chapter 1 called? It's a great question. I thought of it myself. Picturing distributions with graphs. Okay. So we're starting with the very beginning. Can someone tell me what statistics is used for?
Analyzing data.
Analyzing data. That's certainly part of it. Could anyone give me more that might be involved with the practice of, the basic practice of statistics besides analyzing data? Which, by the way, is a huge part of it. Collecting data. That's correct. Analyzing data, collecting data. So probability, it's a good answer. Probability is certainly used in statistics. And in this course, we will certainly have a few chapters straight up on probability, because you can't do statistics without probability. But I guess technically it's two different topics. But both answers that I really liked were analyzing data and collecting data, because they both involve the word data. Statistics at its core is the study of data. And when you study data, you have the objects that you're looking at. And that's the very first definition, which we're going to start with. So definition: individuals. Individuals are the objects. That's not the word are. Individuals are the objects described by a set of data. Now, individuals can be people if I'm studying people, but they can be anything. They could be cars, they could be planets, they could be grains of sand. Anything that you have any interest in, for whatever reason, would be the individuals that you're studying. And what we care about are not the individuals themselves. Okay, I don't care about you if I'm analyzing students at CSUN. I care about your properties. So a variable, this is the definition, a variable is any characteristic of an individual. So for example, if I'm studying students at CSUN, if those are the individuals of my study, what might be some variables that I might care about?
What year they're in.
Okay, freshman, sophomore, junior, senior, their majors, their height. I mean, there's lots of them. Interestingly enough, their age, I saw whether they live on campus or not, 100%. In fact, that's a great one, because their majors and that question are actually very different than the others in a way that I'll explain in a second. I'm actually surprised that nobody said what is probably your greatest concern when it comes to gender, yes, when it comes to you as a student. What is the probably your biggest, as a student, the biggest variable of a person or yourself that you care about more than any other?
Personality.
From a student's perspective, from a student perspective. What was that? I was thinking GPA. I was thinking GPA, but no one's agreeing with me. No one's nodding. No one's giving me a thumbs up. I just see
I
lots
say
of
grades. Is that the same
oh, you did say grades. You did say grades. You must have said, oh, okay. I was reading them and I forgot what people had said because I don't see it here. But yes, okay. So lots of stuff depending on your study. How about commute time, which is related to whether they live on campus or not. But there's lots of different variables for any collection of individuals. The variables themselves fall into two categories. So variables fall into two categories. Category one is what is called a categorical variable. Categorical variable. Places an individual into one of several categories. Whereas a quantitative variable takes numerical values for which arithmetic operations make sense. And that qualification for which arithmetic operations make sense is very important because I can think of a very specific numerical value or a number that you assign to an individual that is that's not a quantitative variable. It's a category because arithmetic does not make sense. Can anyone think of a number that you would assign to a specific individual that is more of a category than it is a quantity that you can do math with?
Zip code.
Age?
So I heard and saw three answers, one of which was correct. And the answer was zip code. Your zip code, if your zip code is 92648 and somebody else's is 43751, you can't claim something like, oh, well, if you live halfway in between, your zip code will be the average of those two numbers. That's not how zip codes work, right? You can't do math with zip codes. It makes no sense. However, GPA and age, you can, right? If I'm 30 and you're 20, then our average age is 25. That is perfectly reasonable and certainly makes sense. If your GPA is 4.0 and mine is 3.0, on the average 3.5, that's perfectly reasonable. So if you can do math, it's a quantitative variable. If you can't do math, even if there's numbers involved, then it is a categorical variable. What's a categorical variable besides numbers? Can anyone think of a situation where you might have a categorical variable That's got nothing to do with numbers themselves. Street name. Sure. Street name is a category. Those who live on State Street, those who live on Nordhoff, those who live on Zelza, hair color, city, what kind of animal you are, ice cream. Oh, ice cream flavors. That's a good one. See, now I'm hungry. Okay, why would you do that? Seriously, that's just wrong. But ice cream flavors, I mean, we all know the answer is cotton candy ice cream, right? If you don't think, what was it? Did you just shake your head? Did you?
That's the worst flavor.
Stop that. Just stop. Okay. You're talking nonsense right now. You're talking not, this isn't, let's just move on because we obviously. Okay. So are there any questions on what we've done so far? Which is basically section 1.1, because that's it.
I have a question.
1 point, yeah, go ahead.
What's the last word on the second group?
On this one here,
No, right before the period.
this one here.
Oh, sent. Okay, that's like
Makes sense. Makes sense. If you're complaining about my handwriting, that's even worse than saying cotton candy is not the best ice cream on the planet. So I'll try to be better at it. Thanks. Okay. Anyways, so chapter 1.1, I guess we can label this here in the beginning as 1.1, so we know what's associated with which each section. 1.1 is just a difference between individuals and variables. Again, the individuals are the objects of study, but the variables are the characteristics of those objects that we are investigating. And I spelled categorical wrong. Categorical. That makes more sense. All right. And then variables fall into two categories. You have your categorical ones and you have your quantitative ones. And the reason why it's so important to differentiate between them is because we use different types of diagrams or pictures to describe each one. If it's categorical variables, we have specific pictures that we use. And if it's a quantitative variable, we have specific pictures that we use, and we don't mix them. So let's start section 1.2, looking at categorical variables. So I'll change to green. So categorical variables. And this one was, section 1 was labeled individuals and variables, just so that we have the title for it. Okay, categorical variables. Who knows, not because they're looking down at the book, because they happen to know beforehand, but who knows the two types of pictures that we use to, as a general rule, to graphically visualize data that comes from a categorical variable situation. Okay, good talk. I'm glad we had this give and take here. So the answer is pie charts and bar graphs. Okay, when it comes to a categorical variable, the two types that we're going to use are pie charts and bar graphs. And you've probably seen a pie chart before. I assume you've seen both before. But before we can show them, we have a very important definition. And this was kind of alluded to here when the chapter's name was picturing distributions with graphs, but we've never really explained what exactly a distribution is. So the distribution of a variable tells us what values it takes and how often it takes these values. So for example, suppose I was interested in the majors of every CSUN student. I might send out an email to every student at CSUN offering a $10 million reward if you respond, to make sure that I get responses. And then of course say, I lied, I just wanted the response, so I don't have to give any money to them. And say, I want to know what your current major is. Presumably, if I did that, I'd get a full response. Everyone would respond. And what I would have is a listing of every single major. You're all obviously math majors. I know you're not gonna say anything. It's obvious, but you have all the different majors of the university, and I can create a tally of how many had each major, and that will be my distribution of the variable majors at CSUN. It's a listing of all of the values the variable might take and how often it takes those values. All right, it's a very straightforward definition, which will very soon get complicated when we switch to numerical or quantitative variables. Because for example, if I'm interested in the average, not average, sorry, if I'm interested in the distribution for heights of every CSUN student, then if you really think about it, no two CSUN students would have the same height. Because if I get to the 10th, 11th, 12th, 20th, millionth decimal point, and somehow manage to have incredible precision to be able to figure out the exact height of every person, no two people would have the same one. So how do I handle numerical situations where you have a range of values as opposed to categorical, where it's either this or this or this and so on? So when we get there in section 1.3 or 1.4, we will learn how to answer that question. For now, categorical variables, categories, and how often they occur. It does not have to be how often they occur. There's another way of describing the distribution. Can anyone think of another way besides how often each outcome occurs?
Frequency?
Frequency. Excellent. What percentage of the time each one occurs? It makes no sense to say it occurred 10 times if I don't know how big the space was, right? 10 out of 100, 10 out of a million is very different. But 10% of the time, that might be in some situations more illustrative. So to continue, the distribution gives either the count, which is the frequency technically means count, or the percentage of individuals who fall in each category. So far, so good. Any questions? Are any of you thinking, wow, stats is so much easier than I thought it was going to be? Oh, just wait, Non-cotton candy girl, we'll see what it's like. Okay, so moving forward. What exactly is, what does a pie chart look like? Well, pie charts look like circles. And what you're going to have is you're going to have little wedges something that might look like this. And what does each wedge denote?
A variable.
Not a variable, because the whole thing is the distribution for a single variable. The whole thing is one variable. It's a category, right? If the variable, for example, is something like favorite sport, you might say, oh, okay, well, a lot of people's favorite sport is soccer. That would be one value that the variable can take. What else we got there? Who else likes a sport besides soccer?
Basketball.
Basketball. Okay, that's a pretty popular one. So I'll put that there. All right, anything else?
Track.
Sorry?
Track. Track. And
Track.
field.
Track. Okay, so we'll put that, let's say here, track. Someone said baseball. Baseball's a popular one. And what else we got? No one said favorite sports, huh?
Someone said volleyball.
Volleyball. Okay, whatever. Okay, volleyball. What else we got? My favorite, swimming. Okay, I'll leave that out because I want to have my favorite sport in there, but no one's saying it yet, which is really weird. Keep going, keep going. Okay, there we go. Tennis. Yeah, that's what I'm talking about. Tennis. Yeah. I personally am on 3 tennis teams, so I really like tennis. And then there's lots of other sports. And my pie chart is basically done. I only have one remaining category. So what would I write for the last category? If there's so many other sports. Other, right? I can write all the other sports, I'll lump them together into one. Of course, golf is not there. It's a great sport too, but okay, you go. So it's one variable. The whole thing is one variable, and you list different values. Now, how do you determine the size of each wedge?
By the number of people who said it was their favorite sport. Like,
Excellent. Right, so the size of each wedge is commensurate with the frequency, or more specifically, the percentage of each value the variable takes. And then when you do pie charts, you can spruce it up a little bit, different colors to differentiate them. You don't want to do too much that would lend importance to some categories versus others. Like you don't want to change the fonts that you're writing with, or change the size, which I think is the same thing as fonts. What's it called when you change the type? Is it just type? I don't know, but you know what I'm saying. So you want to be kind of uniform across the board. The only thing is the actual area of each wedge should be commensurate with the percentage. Okay, so you've all most likely seen pie charts before. This is not really new, correct? How do I, or what is another graphical display for a categorical variable besides the pie chart? It's I already gave it away, it's the bar graph. Okay, now when we do quantitative variables, we're going to have something called a histogram. A histogram is different than a bar graph. They have differences. A bar graph has the different categories on the x-axis. So soccer and tennis, and so on, all the different categories on the x-axis separated from each other. And what you have is you have these columns, these bars to represent the same thing, frequency or percentage on the y-axis. It's important that the bars be the same width. You again don't want to visually complicate things by assigning different values because it's wider. They should all be very uniform. Some graphs, you might have the bars go from highest to lowest or lowest to highest. You might have them scattered. That's a personal preference. But the same information is provided in the bar graph that is provided in the pie chart. They are different ways of displaying data. And I wouldn't say either one is better than the other. Depending on the scenario, you might prefer one to the other. Let's say you had 50 categories. Which of the two do you think you want to use?
The bar.
Why? I'm not saying you're wrong. I'm just saying why.
Because it looks displayed easier just to look at.
Yeah, how are you going to fit 50 names, 50 types of categories in a relatively small circle? Right. So there are times that one might be preferable than the other. But in theory, either one of them is okay to use in all scenarios that the other one would be. Does that make sense? Are there any questions so far on anything we've done? All good? Okay. Let's do the following. So I have the workbook here. I'm going to pause recording for just a second. Okay, so now that we have the workbook, which is hopefully downloaded, I am going to go through the problems. So there it is. Okay. Okay, so the workbook. So let's go through question number 1. This is question 1.1. Fuel economy. We all see it? Hopefully. Yes, no, maybe so.
Yes.
Okay. Okay, so it says, here is a small part of a data set that describes the fuel economy in miles per gallon of model year 2019 motor vehicles, make and model, yada, yada, yada. Okay. The annual fuel cost is an estimate assuming 15,000 miles. Okay, fine. A, what are the individuals in this data set?
The type of car.
So listen to me. What are the individuals? Make and model is not the individuals. I'm looking for the actual individuals. No, definitely not fuel economy. Yes, exactly. The individuals are the Subaru I don't even know how to pronounce that. That's the first individual, the first specific type of car that I'm studying. The Nissan Rogue Sport, the Hyundai Elantra, and the Chevrolet Impala. These are the actual individuals because all of the variables, all the columns that come next are characteristics of those 4. So when he said make and model, I'm pretty sure I knew what you were trying to say, but it wasn't technically correct. Agreed? Hopefully. Utter silence. I never know what that means. Okay, part B. For each individual, what variables are given? And which of these variables are categorical and which are quantitative? And in what units are the quantitative variables measured? So we're answering a lot at once. Somebody give me one variable. Pretty pleased with the cherry on top.
The vehicle class?
Okay, the first one is a vehicle class. Would that be categorical or would that be quantitative?
Categorical.
Certainly categorical, right? They're not even numbers. So if they're not numbers, it's definitely categorical. Then I saw someone say transmission type, another variable, and categorical or quantitative.
Categorical.
Categorical again. Another variable, please.
Vehicle weight.
Vehicle weight. I don't see that here. Do you? I'm not saying it's not a variable, but it doesn't look like it's a variable that I'm studying in this particular study. Do you see it? Hello?
No.
No. So it is a variable, but it's not one that I'm currently studying. So the next one is number of cylinders. Do you see the page that we're all looking at?
Yes.
Okay.
Well, me or the other person?
No, you, because you're the one.
Yeah, I
who's-
saw the page. I saw the page.
Okay. So number of cylinders, categorical or quantitative?
Quantitative.
Quantitative. Not just because it has numbers, but because you can average them if you want. Next one. Now, well, by the way, what are the units of that? For what? 6 what? What are the units? Huh?
Cylinder?
Cylinders. Yeah, that one's easy. All right. Number of cylinders, 4 cylinders. 6 cylinders, right? That one was silly. Almost like a trick question. Next variable. Anyone?
City.
City MPG. Numerical or quantitative, categorical or numerical, categorical or quantitative.
Quantitative?
Quantitative. And what are the units?
Miles per gallon.
Yeah, exactly. Miles per gallon. Next one.
Highway miles per gallon.
Highway miles per gallon and categorical or quantitative.
Quantitative.
And units are again miles per gallon. And then finally, the last one is annual fuel cost. Categorical or quantitative?
Quantitative.
Quantitative. And what are the units?
Dollars.
Dollars what? Is it dollars?
Yeah.
Cost.
Oh,
Dollars per year I like better. Since it is an annual fuel cost, it tells me how much it's going to cost per year, correct? Agreed?
yes.
Yeah, okay. So that question was fairly straightforward, I hope. Not totally, but fairly. Let's go now to question 1.13. 1.3. Okay, 1.3. Social media preferences for younger audiences. So go ahead and read that. And then let's answer part A. We're not doing the workbook does not have every problem in the text. There's just hundreds and hundreds and hundreds and hundreds of problems. So the math department, whoever coordinated this course, has picked out these particular questions as the ones that are most illuminating for the concepts that we're covering. So yeah. All right, so part A, what is the sum of the percentages for these top social media sites?
Is it 90?
How much?
90?
90%, which tells me what?
90% of people ages 12 to 34 use this.
Sorry, my volume was down. Could you do it a little louder, please?
Does it tell you that 90% of those ages 12 to 34 use the top social media sites?
Okay, so what about the other 10%?
That's other, they use other sites.
Okay, so exactly. So what percentage of Americans use others? That's 10%, right? 10% is others and 90%. Okay, so that was fairly straightforward. Now B, let's make a bar graph to display these data and be sure to include an other social media brands category. And it's very important when you make a bar graph that your bars are the appropriate heights. And what I mean by that is your scale better be correct, right? Don't have this as a height of 10, this as a height of 5. Okay, oh, but it's smaller, so I made it a height of 5. No, that's not a height of 5. If it was really a height of 5, how high should it have gone?
Half of 10.
Half of 10, exactly. The height should be exactly half as much. So in this case, let's go highest to lowest. So Facebook will have a height of 29. The next one is which one?
Snapchat.
Snapchat, which has a height of 28. So that's basically, right, just a little bit lower. Fortunately, these numbers are fairly close. Instagram at 26. Right, Twitter at 6. And then Pinterest at 1, something like that. Oh, and then we gotta do other, right? What's other? Forgot about other. How much is other again?
10%.
10%.
So other 10% would be something like, I don't know, like this. I know it's not perfect, but my artistic abilities are not the greatest. So hopefully the idea makes sense. Does the idea make sense?
Yes.
Yes.
Okay, I mean, you can see my other width is really wide compared to the rest. That's not the greatest, but you know, I blame my lack of an art teacher growing up. Okay. Would it be correct to display these data in a pie chart? Why or why not? Could I display these data in a pie chart? Was that yes answering the question I just asked, or was that from before? I just saw it.
For the question you just asked.
Yeah, sure. Why not? They're both, it's categorical data. And why not? Right? 6 categories. It's not too tough to put into a pie chart. So yeah, why not? Right? Why not? I guess, I mean, maybe that's not the right thing to say. I'll just say yes. Okay, with me so far? Let's go ahead now and let's switch colors. New question. Someone pick out a color for me.
Red.
Red. Okay, so now we do 1.13. It said, here are the first lines of a professor's data sets at the end of a statistics course. Sura, David, Annette, Sun, and Maria. They had 5 majors, they had their total points, and they had their grades. The individuals in these data are A, the students, B, the total points, or C, the course grades. What are the individuals here? And I guess looking back to that first question with the make and model, I guess now technically I had to say, yes, you were right when you said the individuals were make and model, even though I love them to be like the actual ones. But yeah, so the answer is the students, right? The students, the individuals that we are looking at. Okay, well, that was easy. All right, next color. Anyone?
Blue.
Blue, okay. So question 1.14. According to the National Household Survey on Drug Use and Health, when asked in 2017, 31% of those aged 18 to 25 years said they had used cigarettes in the past year. Oh, for shame. 7.7% said they had used smokeless tobacco, and 39.4% that they had used illicit drugs, and 7.8% that they had used pain relievers or sedatives. To display this data, it would be correct to use A, either a pie chart or bar graph, B, a pie chart provided that a category for other is added to get to 100%, a C, a bar graph, but not a pie chart.
B.
So I have a couple B answers. I have some A answers. I don't really like this question. I don't think any of them are correct. Why not? Well, first let's do the following. Anytime that a pie chart or a bar graph is used means we're dealing with a categorical variable, which means both of them can be used. Okay, if one of them can be used, both of them can be used, as long as the percentages add to 100%. So I would need an other category for the pie charts, because if I add up the percentages here, 31, 7.7, 39.4, and 7.8, they do not add to 100%, do they? Correct? Right? You with me?
Yes.
So if I don't add a other category, then I can't use a pie chart. Bar graph I can. I don't need an other category for a bar graph. Nothing says for a bar graph they have to add to 100%. For a pie chart they do, because the circle is the full circle, 100%. So because of that, I would throw away A and possibly allow B, and I would throw away C. So of the three, B is the only one that seems reasonable, but I don't like it. Unless I'm misreading the question. Tell me why I don't like B as an answer. Anyone see it? There's not really a math. No, it doesn't say bar graph. No, that's, what does it say instead?
It like explains that you need to get 100, kind of. It
Well,
like hints that it's the answer.
maybe I'm misreading this, but is there anything that says that a person can't say yes to more than one option? What if a person used drugs and smoked cigarettes? Wouldn't they be included in more than one option? In which case, you can't really put them in a category because they would put into more than one category. You see what I'm saying, or am I sprouting nonsense here?
I see it.
I get it, but then wouldn't it be neither of the?
Yes, so my answer when I read it is neither A, B, nor C. Because I wonder if they cut something off when they translate. Yeah, they don't really say one way or the other. Maybe I'm just reading into it too much. So maybe, maybe it's implied that they only answered one each, but they didn't say it. So I really don't like this question. I'm going to give a stern talking to the authors. But if we assume that they can only do one each, then it should be, again, none of them, because you should have a pie chart or a bar graph. So this is it's a very strange. Okay, I don't like this question. We're gonna come back to this one, and I'm gonna ask someone what is going on here, because this one is just making no sense to me. But I hope that what I'm saying is making sense to you as to why it makes no sense. Does it? Is anyone following along with what I'm saying as to my reasons why this is bad? Because now I'm saying even B I don't like, because B doesn't say bar graph. So I really don't like any of these three. Unless there is no other. Unless there is no other. And therefore, well, the other would be none of them. It's a very bad question. What's the last word of this question? What do you mean? It's all here.
I want to know what you wrote.
Oh, I said, ask someone what is going on here. Because I don't like this one at all. So let's move on to the next one. And I'll pick a color here. Let's go black, 1.15. It says a description of different houses in the market includes the variables square footage of the house and the average monthly gas bill. A, they're both categorical. B, they're both quantitative. Or C, square footage is categorical and average monthly gas bill is quantitative. A, B, or C. Pop your answer in the chat box. And don't be afraid of being wrong. I'm wrong all the time. So I have a 5, 6, 7, 8. I get a lot of people so far. Either we got major peer pressure going on or everyone got the right answer. But yes, they are both quantitative variables, so the answer is certainly B, quantitative. All right. Question 16. Let's go orange. A political party's data bank includes the zip codes of past donors, such as all of those things. The zip codes is a quantitative, categorical, or unit of measurements. Uh-oh, I hit a bad button. There we go. Zip codes, categorical, quantitative, categorical, or unit of measurements. Bees. So yeah, categorical, I already gave this example, so this one should be a no-brainer if you were paying attention. But zip code, even though they're numbers, is certainly categorical. How many more do we have here? We didn't finish chapter 1 of the book, so this is a histogram. We got to skip it because we're not ready for it yet. Stem plots we're not ready for. I can't use those yet. Okay, so let's go back to the book. All right, we have covered section 1.1 and section 1.2. Okay, so now let's continue to section 1.3. And 1.3 is now on quantitative variables. In particular, histograms. The histogram is not the only graphical display that we use for quantitative variables. There will be another one that we use, but that's not for a couple more sections. So right now, quantitative variables, specifically a histogram. A histogram kind of looks like a bar graph, but there's a big difference. In a bar graph, you have bars and categories, right? This is a bar graph. Bar graph has bars and categories. For a histogram, we don't have categories because it's not a categorical variable. It's a quantitative variable. So we're gonna have bars, but those bars are gonna be attached to each other, possibly with gaps, if you don't have any values, let's say, in that region. And what you're gonna have is something like 10, let's do it like this. Let's say you have something like 10 to 20 to 30, 40, 50, 60, 70. So what the histogram represents, it's still going to be frequency or percentage on the y-axis. That part hasn't changed, frequency or percentage. But now it's how many fall between the numbers 10 and 20, or between the numbers 20 and 30, or 30 and 40, 40, 50, 50, 60. First of all, do you see why we need the gap here? Gap, if there are none and if there are no values in that block. Right? You're allowed to have gaps like you do for a bar graph. And why would you have a gap? Why would you have a nothing there if there's no values in that section? In this example, can someone describe for me the first bar of the histogram? Which numbers would make me tally a mark in that first bar? And be very specific about what those two numbers are. The very first bar here goes from what to what, and be very, very, very clear. And hopefully you can all see it. It's not too small. So I see some 10 to 20s. I see 10 to 19. I see 11 to 20. I see 0 to 10. Well, 0 to 10 would be this region here. And I didn't have anything in that region. But so far, I have not seen the correct answer. Still no, still no. Okay, so those of you who are saying start at 11, oh, 10 to 40, where'd that come from? 10 to 40 is like 3 bars worth. So first, those of you who said 10 to 24, where did 24 come from? So, okay, so no one's right, which is great because that means everyone gets to learn. Those of you who said 11 to 20, where would 10.5 fall? And those of you who said 10 to 19, where would 19.5 fall? Sorry, ears must not be working. I didn't hear anyone respond. The middle of the bar. So here we have to be very clear about this. The bar is only counting how many fall between this number and that number. And the question I'm asking is, what number do we start and what number do we end for the first bar?
Would it be 10.0?
10.0 to what?
20.0?
So that was one of the very first answers, 10 to 20, with a question mark, but I'll count it. And that's not correct. And the reason is as follows. If you're gonna say landing on the left, oh, okay, so now we got a better answer there. Still not 100% correct, but much better. If we say landing on the left edge of the bar puts me in that bar, then landing on the edge of the next one would have to put me in the next bar. And therefore, it should be 10 inclusive to 20 exclusive. Have you seen this notation in algebra, the difference between a bracket and a parentheses to indicate the boundary points? So we're starting at 10, but we're not quite getting to 20. We're not getting 19.999 or 19.9999999 or 19.1009. We're going as close as we can get to 20, but not quite there. If we actually landed on 20, we'd have to go in the next one. Or maybe it's the other way. And you want things to go to the left one. That's your choice, but you must be consistent across the entire histogram. Does that make sense? So you have the lower end and you have the upper end of each bar, of each piece of the histogram. And that dictates whether or not we put it in that bar's tally. And the bar goes up or the bar goes down, depending if it does or not. Does that make sense? And I just looked in the book and I remembered that they call it classes in that class, not in that block. I've forgotten the word in that class. So each of these bars is a class. How do you know how many bars to make for your histogram? The answer is there's no hard and fast rule, which is how some people use statistics to, I wouldn't say to lie, but to make it seem as if the data supports one conclusion versus another conclusion. So if I would use 10 blocks versus 20 blocks, I might get a different graphical conclusion and therefore, do different things. So there are ways to have your data displayed so as to influence. But in this class, we don't really need to worry about that. Usually I think always you'll be given class sizes, or it'll be obvious like 10 or 1 or something like that. And you just make your classes. Every class has a lower bound and an upper bound. You count how many fit in that category and you tally it up. Does that make sense?
Yes.
Okay, are there any questions on this at all? On how to make a histogram? Going once, going twice. Okay, so in that case, we're gonna end a few minutes early. I'm gonna stop recording.